Now it is time to discuss the DMAIC tool. DMAIC is based on the scientific method. So first we'll learn about what it is, and the simplest implementation of the scientific method is known as PDCA. Scientists have been using scientific methods since 17th century and achieved wonders of the modern civilization. Scientific method involves careful observation, creating hypotheses, designing experiments and tests, performing those tests and experiments and recording the results. Finally, evaluating the results and drawing conclusions. PDCA is a simple application of scientific method. We need to plan work, then do the work, then check the results, and only then take action based on what we have learned. This approach could be applied to anything that needs to be improved. For example, to customer relationship, quality, productivity, engineering, efficiency, or even to personal projects. PDCA sometimes is read as plan, do, check, adjust, and in a way, acting based on the results and checking is adjusting. But sometimes it could also mean complete redesign or rethinking, or even redefining the problem. DMAIC methodology is well aligned with scientific method, and it is a solid framework to run medium to large quality improvement projects. DMAIC stands for Define, Measure, Analyze, Improve, and Control. So let's review each step. Define. First, you need to define what the issue or problem is in the process. And a good question to ask: is it an important issue, or there are more pressing problems? Measure. Measuring could be a very challenging task and require engineering of a modern data collection system to measure process variables. Also, it could require a lot of manual labor if measurements cannot be automated. However, without data and measuring it, it won't be possible to evaluate the current state or the progress. Analyze. The questions to ask in this phase: what is the root cause of inefficiency? Is the process too slow? Is there lots of defects or errors? What is waste, and is it time or the materials? In improve phase, you should ask yourself the following questions. What needs to be done to eliminate the waste? Is our process too complex and leads to lots of errors? Can we eliminate a step or two to increase speed, or quality checks are required? How can we reduce variation? In control phase, you will ask the following questions. How can we ensure that we will sustain the performance? Should we plan maintenance of equipment more often? Do people need more training? And how do we validate and verify that the improved process is sustainable? Six Sigma Management System is a high-performance system and a top-down solution to help organizations to align their business strategy to critical improvement efforts, create teams to address high-impact projects, accelerate improvements and get business results right away, and ensure that improvements are sustained. We can say that the output is a function of input, and it writes as y is function of x. In every process we have outcomes, and those outcomes we call dependent variables, and process inputs we call independent variables. So look at this table. Dependent variables D, their outputs, effects, symptoms, and we monitor them. Independent inputs I, their input to the process, their cause or a problem, and we need to control them. We can map the project flow and summarize it in the following table. And before we dive deeply in the content of the table, we will review project management fundamentals. And in that section, we'll review this table in details.